song you just heard in the title was Not Fade Away. It's the Grateful Dead playing a Buddy Holly song. Buddy Holly was a rock and roll, one of the first people who came out with the rock and roll sound, and this was in like 1959, 1958. And on February 3rd, which is today in 1959, he was in a plane and it crashed in Iowa, and it killed him and then two other really famous musicians at the time. They were at a concert in Iowa, and they decided they were going to take this plane. Obviously, the plane crashed. My son Joey, and I were at a hockey tournament. We stayed in a hotel, and we thought it was strange that the hotel had these pictures, and they were all of famous rock and roll singers, especially Buddy Holly and the other people who were in that plane crash. And we're like, well, what's going on here? And they're like, oh yeah, this is the place. This is where this plane crashed. And it actually was the day that it had happened, in February 3rd. I mean, obviously it was a lot of years before that, but it was on February 3rd. So Joey and I went to the place where they last played, and then we went to the field where the plane had crashed, and there's a memorial there. So it's pretty neat. Anyway, what we're going to do is there's a section I'll go through with you how to do the two-step equations, and then also some of the tricky ones that might show up on one of the IXLs that gets kind of tricky. And then you will have time to work on those IXLs that you have most people done. Some people done with all of them. There are some people who are way, way far behind. So you need to get going on those things for real. Get going on them, get them done. They have been assigned. You need to do those things. The rest of you, if you are finished, you can kind of go outside. It's a super nice day out. It's going to get cold later, or you can read a book or do some other work. But please get the ones that you need to done, and those people who are behind, get on it. When we're doing two-step equations, always, always, always get rid of the number first. So if you see one that's 3a plus 2 equals 17, you need to get rid of the number first. Always getting rid of the number first. So I want to get rid of a plus 2. We're going to pretend this is just like the one-step equations at first, so we're not going to worry about that 3 times a. I'm going to get rid of this 2, and to do that, I need to take away 2 from this side, take away 2 from this side. This becomes 0, so we already know 3a equals 15. Now, second step. So that was the first step. We got it. We got rid of the numbers. Now we need to get rid of this multiplication problem. So it's 3 times a. We would divide this side by 3, this side by 3. 3 divided by 3 is 1. So 1a, and we're just a, equals 5. Then we check it back. 15 plus 2 equals 17. So always getting rid of the numbers first. So 4x minus 5 equals 20. No, it must equal 23. Okay, so 4x minus 5 equals 23. A couple ways to do that. I could make it plus negative 5 and try to get rid of that negative 5. Or I know it's subtract 5. I just add 5 to it. Getting rid of the numbers first, so I get 4x equals 28. I need to get rid of that 4 times x, multiply by 4, it becomes 1, so I get x equals 7. And 4 times 7 is 28, minus 5 is 3, checking my answer. The next one that I have you do is one that's like a over 5 equals, plus 3 equals 9. On this one, still, even though it's a division problem, getting rid of that 3. So it's a plus 3. I'm going to subtract 3 from that side, subtract 3 from that side. I get a over 5 equals 6. I need to get rid of that divided by 5. Multiply that side by 5, that side by 5. That cancels out. I get a equals 30. And 30 divided by 5 is 6, plus 3 is 9. There's a couple that are a little bit confusing when you get to the higher numbers in some of the IXLs. one of them is, it starts to do this. It'll say a divided by 2 equals 10, or they might throw something else in there. If you see something like that, just rewrite it. A divided by 2 is a over 2. And you know how to do that by multiplying on each side. There's one of them, it'll be like x divided by 2/3. Now this is the tricky part. This is the weird part. X divided by 2/3. It's not times 2/3. It's not 2/3 x. So you're going to have to take this 2/3. And if you divide by, so x divided by 2/3, isn't that the same as x times 3/2? Yeah, because keep, change, flip. So keep, change, flip. So x divided by 2/3 is the same as x times 3/2. Well, x times 3/2 is 3/2 x. And we know how to get rid of a 3/2 x if this equals 1/2. I need to get rid of 3/2 x, multiply it by 2/3, multiply it by 2/3, and that's going to give me x equals 2/6. It's also 1/3. There are also some weird ones where they'll say something like that c plus 5 over 8 equals maybe 9. Now c plus 5 over 8 equals 9. Very confusing, like, oh, didn't you tell us we need to get rid of the number first? Yeah, but in this case you don't, because the c plus 5 is kind of like in a parentheses, it's on its own. So we need to get rid of that 8 first. So the divide by 8. You really just have to do that. So I want to get rid of the divided by 8. If I multiply that side by 8, gets rid of that. I multiply the other side by 8, and I get c plus 5 equals 72. So yeah, that seems weird, but you have to do that because the 8 on the bottom is actually the same as c over 8 plus 5 over 8. Just get rid of it. Makes it easier. Then we just have to subtract 5 from each side, and we find out that c equals 67. Same type of problem would be z minus 8 over 10 equals 2. So z minus 8 over 10 equals 2. I need to get rid of this 10 first. So I'm going to multiply both sides by 10. Gets rid of the 10. I just rewrite it. Z minus 8 equals 20. And I just finish it up. It's just a one-step equation after that. Add 8 to that side, 8 to that side. I get z equals 28. And that does work. Because 28 minus 8 is 20 divided by 10 equals 2. Trust me, just get rid of that division sign first. You'll also come across some problems that have a distribution in those. So it'll be like 5x plus 5 equals like 10. You're like, oh, okay, do I have to distribute this first? So I distribute it first and then do it? You can. That'd be 5x plus 25, and I'll do the distributing. 5x plus 25 equals 10. Get rid of the numbers. 25. I get 5x equals negative 15. Divide by 5. I get x equals negative 3. Excuse me, I'm sorry. That works perfectly fine. You can distribute it and do that. But there is another trick. The other trick is, for distribution, is 5x plus 5 equals 10. This is why we distribute for some of the factors. I can get rid of that 5 without distributing it. I can seriously get rid of that 5. Since this is 5 times the quantity of x plus 5, if I divide this side by 5, and this side by 5. This gets rid of this. Then x plus 5 equals 2, because 10 divided by 5. The number on the outside of when you're distributing before that, you can divide both sides by it. It gets rid of it. So then x plus 5 equals 2. Subtract 5 from each side. I get x equals -3, which is how we did it if we didn't distribute it. I'll show you again. So x times the quantity of a plus 4. I could distribute it. I don't want to. That's annoying. I'm just going to divide this side by 15. This side by 15. They cancel out. A plus 4 equals 10. Subtract 4 from each side. I get a equals 6. And if I go back, 6 plus 4 is 10, times 15 is 150. And yes, it does work. So distributing, just divide by the number that's on the outside. Way, way easier. All right, give it a try. If you have any questions, you can email, or you can just make, we can work on it in class or talk about it, and we will in class.
I'm gonna tell you how it's gonna be. Are you gonna give your love to me? I wanna love you night and day. You know my love